this is the first part in my lecture series that I'm doing on genetically modified organisms. And not only is this first part of the GMO period portion of lectures, but also it's the first lecture of the lecture series. And it's an overview, includes the detrimental effects on food and oil prices. Okay, so we have essentially two different types of seeds. You're going to have your genetically modified organisms, your GMOs, as well as your high-yield varieties. The genetically modified organisms require an actual change in the DNA structure of the crop. And that's actually a really hard thing to do, to accomplish. Scientists found that the only way to actually do this was by utilizing yeast, because yeast is a living organism, and they were able to splice in the genetic changes into the seeds. Obviously, seeds not the most complex DNA structure for a plant as compared to living a mammal or an actual animal, a reptile or whatever. But so that's the difference. A genetically modified organism actually has its GMOs structure, DNA change, whereas a high-yield variety is going to be a hybridized seed. Pretty basic stuff. You're going to cross-pollinate a short variety of maybe a corn plant and a tall variety that maybe has a better fruit production. So you're going to end up with a medium-sized plant and with a larger fruit. And then you can splice that again and hybridize it again with the shorter plant, and that'll produce the next level down, an even shorter plant, until you get the type of traits that you're looking for from the crop that will grow better in certain types of production environments. Like if you have a strain that's better at adapting to drier, more arid climates, like in Mexico, but yet, so you would want to implement that type of a plant in another drier environment, maybe globally, and you could take the traits for each of those plants and basically hybridize them to the needs of your environment, and over time, you're weeding out undesirable traits for particular environments. Not going to get too much into the patenting of seeds and things like that, because that's not the point of this video. So hybrids, generally, probably okay, right? Hybridizing a seed sounds like normal agriculture. I'm sure that God has no problem with that. Splicing in DNA into a different type of seed, that can be questionable, especially you've heard about, taking DNA from a fish or something, a reptile, splicing that type of DNA into a plant, or, the Frankenfish concept, where you're splicing into the fish to make a large fish. That's probably not normal. It's probably not something that is in line with the natural order of the universe, that is God's order. So, not necessarily the point of this video. Now, the main point, the main reason why GMOs are produced, and why, and even the hybridizing traits of hybrid plants, is so that they can withstand large amounts of petrochemical inputs. So petrochemicals, petroleum-based chemicals to improve the plant growth production and the agricultural production to, in turn, create higher yields in the end, which is what this is about, getting more food for people. So one of the big ones is going to be ammonium nitrate and anhydrous ammonia. Anhydrous ammonia is a gas form, whereas ammonium nitrate is going to be more of like a salt form. So there's different forms that you can use. Using the gas application of nitrogen is more dangerous. It's obviously explosive, and that's why FBI tracks it. Just throwing that out there. And if you remember, I'm not going to go there. So, but we see the difference between the two plants, right? Here's a nice picture for you. We have the fertilized versus the unfertilized plant. Obviously, the fertilized plant that has the nitrogen is going to produce more luxurious leaves, more luxurious fruit. Problems with it, it's hard on the soil. There's more problems with it. We're just focusing on the necessity for the GMOs, not necessarily to produce higher yields, but to be able to withstand the petrochemical inputs that create the higher yields. So you're not necessarily genetically modifying or hybridizing a plant so that you'll create higher yields in itself, but that the plant will be more resistant to harm and able to take in the large amounts of petrochemical inputs that are required for mass agriculture production. Okay, so also there's the aspects of pesticides and herbicides, most notably known as Roundup, created by Monsanto. Just throwing it out there. Also was the person who was the group, the commercial industry, who produced Agent Orange, which was used in chemical warfare in Vietnam. And by the way, chemical warfare is no longer acceptable in the global war plans. We have certain practices in modern warfare that are acceptable and those that aren't. Chemical warfare, biological warfare are no longer acceptable, and a lot of people will debate whether we're having biological warfare right now by maybe attacking different aspects, maybe the food, whatever. Not even trying to go there, but mentioning it because this is anonymous. This is the safe place where we can talk about some of these things that we can't normally talk about in usually a lecture hall. Although Agent Orange was actually created in a university. So moving on, glyphosate is created using the petrochemicals. So now we're going to talk about Thomas Malthus. Thomas Malthus, late 18th century, early 19th century philosopher and economist out of England. Most notably is known for Malthusian Theory. Well, Malthusian Theory is obviously named after him, but he's known, his essay on the principle of population is the central founding document, basically, on population growth. So basically, Malthus says population growth outpaces food production. And so why is that? Because basically what he states is that food production increases arithmetically while population grows geometrically. And that at some point there's going to be a point of crisis. Okay? So what does that look like? On a graph, it looks like that. Population grows in an exponential form and resource increases in a linear form. So you have a non-linear curve versus a linear curve. And to just think about this simply, I didn't invent this statement, okay? This lecture that I'm giving is more or less exactly the lecture that I received in college from someone who had a PhD from Harvard. So, so I'm telling you that so you take this as credible. Wash everything else away. These are the facts. This is the central core of the argument. So they say basically because one man can impregnate an entire village. Now, although there are some constraints there, the principle holds. So let's just think about it in more common sense terms. So maybe you have two couples, they have 4 kids, now you have 6. Then those two couples each have 4 kids. So that's now 8. So we went 2, 4, 8, and then we're going to continue 16, 32, 64, 128, 256. Everybody knows this because this is the core of binary. So eventually we're going to come to a point of crisis. Now, Malthus said that this point of crisis will come before the 1900s. So they've been expecting this crisis to happen, and it hasn't. Now, you have to put Malthus in his place in time. He's in England at the time, and England is obviously on an island. England and Scotland share an island. And at the time, in the late 1700s, there was the population growth of England was coming to the point where people were really filling up the island. And we're not going to talk about the socio-political structure of monarchy and nobility and how you have workers work on specific plots. Although it is interesting to note that some of the women were able to produce their home growth rates and higher levels of output than the men who were working on the nobility's land. And that's an interesting socio concept that developed in that time period. And it has application to this conversation as well, but not to this specific point. So basically, that's it. Population growth will outpace resources because, again, let's say you have 1 cubic foot of land. That cubic foot of land can only produce X amount of food output. So land is obviously a fixed and finite resource. And this is where kind of England is concerned, where it's on a specific fixed point. Like, people have been to both sides of England, whereas maybe a place like so many other continents, you have been both to the East Coast and the West Coast of that place. But definitely in England, you probably have. So he's thinking a fixed amount, and he's seeing, families having, 8 kids, 10 kids, 5 kids. And then this is where we're going to have a different conversation about population growth in a different lecture. But that fixed resource of land can only produce one amount of food, whereas the population around it is utilizing that same fixed amount of land to produce, to sustain itself and to grow. And of course, at the time, Malthus hadn't seen the rest of the world and seen how much resources and space there is globally to understand that it's not as fixed and finite as he first assumed. So anyway, this is where the theory comes from. Not saying that the theory is correct, but that a lot of people believe in it. For example, people such as the Club of Rome in 1968 was formed. Now, 1968 is not that long ago. We're really only coming to the end of that period and that scope of time that those people were applying for. Only now are we really beginning to question maybe a lot of those people who believed in those principal fundamental things, like this last wave of politicians and people that manipulate and control the world. just the shot callers. So it doesn't matter who they are necessarily, but that philosophy is coming to an end. So anyway, they published a document in 1972, or 73, called The Limits of Growth. 30 million copies of these disseminated across the world. 30 million is a lot. Now, we're talking about the population of the United States at that time is only like 150 million. So to think like 30 million, and these are going to many of the educated heads across the world. And this was an international group comprised of people from all over the world. And they're called the Club of Rome because it was established in Rome. And they published The Limits of Growth, which basically has the same implications. Again, Malthusian Theory. Eventually, that population growth will outgrow the resources that are going to be available to supply it and sustain it. So, enter the Green Revolution. Now, essentially, the Green Revolution came about because there was widespread famine in India. Rice paddies weren't producing the amount of rice that fed the population. Rice, as you may not know, supports about 60% of the global population. It's the main source of food for the rest of the world. Now, so essentially this guy, scientist, agronomist, whatever, named Norman Borlaug, who's known as the father of the Green Revolution. He basically goes down to Mexico, starts doing research, learns how to splice in DNA and create hybridized plants. A book such as like The Grapes of Wrath, which really places your understanding in time in the early 19th centuries. In the United States and parts of the United States, we have a lot of industrial processes, but as parts out west are expanded, you're still basically living in the Wild West, where you have land and agriculture and farming going on as you begin to implement these new technologies of tractors. So we're moving from plowing plots of land, a horse and buggy, to spreading that out from just plowing one row to plowing now 2, 3, 4, and then eventually implementing the tractor. Now, the Great Depression and the famine and the drought that came in the 1930s really helped to catapult the modern industrial farming processes into existence that we have today. And right in line with that came the Green Revolution. So they call it the Green Revolution because it's increasing food productions. And so what ended up happening, especially during the Depression, is that larger scale farms began to purchase small farms. And so you have family farms, maybe a larger family had been farming for a long time, then begins to buy up smaller plots of land as people aren't able to continue farming methods. Maybe they own a note to the bank or what have you. But basically, they began to consolidate small farms into larger farms. And now over time, where the point where we are now, we have commercial farming that's traded currently on the stock market. And there's very few family farms left. And notice, and I'm completely agnostic to this, maybe not completely, but at least the lecture is. And basically, the point of this lecture isn't that we need smaller farms, and that large farming is bad. The point of the lecture is that this is what has happened. And what has happened is that these large tractors are now, I've seen them, they run 5 or 6 at a time, according to GPS, and They even have air conditioned, by GPS guided all over, and they're able to produce high yields. Well, a lot of the time the applications of petrochemicals that these require is like 3 to 4 times. So from planting to harvest, you probably need to hit them, I think, 4 times with different petrochemical inputs. Now we're going to talk about the point of the lecture, is that oil prices are now tied to food costs. We are demanding that food, commercialization of GMOs and the agriculture methods that they require, which is large amounts of petrochemical increases, have tied food production costs to the price of oil, a barrel of oil. Now, not all oil, the entire barrel of oil, is used to make gasoline. Diesel, gasoline is a portion, diesel is another portion, jet fuel, but each part of it, doesn't have the chemical properties to be used for just gasoline. So basically, different parts of it go to other things. One part of that goes to producing food. So then, on top of that, we're going to demand, politicians have decided to demand ethanol production, increased amounts of ethanol in gasoline. Ethanol, which is made from corn. Corn itself is not all ingestible. We can't digest it all. Maybe that's why during this whole time, in the 1960s, Coca-Cola was invented. It had cocaine in it, perhaps an addictive property. Not necessarily to get people addicted, but to get people to drink corn syrup, which is broken down from the corn and used as a source of sustainment. And we're literally talking about feeding people, not the quantitative methods of feeding people, and not the qualitative methods of what we're consuming. Okay, because remember that ultimately, we're talking about beating a crisis point that we assume is coming, where population growth will outpace food production. So now we have ethanol requirements for gasoline. Having increased amounts of ethanol in gasoline increases demand for more food, which increases demand for more gas. Now, how the numbers break down on that is something that we need to look at. But in generally speaking, the bottom line is demand for oil goes up. The price of gasoline also goes up, we know. But also the cost of food goes up. As we know, there's food grade maize that we feed to beef for commercial farming. The cost of that food for that beef goes up. If input costs for beef go up, so also will the cost of beef. So this is the main issue that we're talking about when it comes to genetically modified organisms and food, is that it's not necessarily to be bigger as much as it is to withstand large amounts of nitrogen, which will make the food ultimately grow more. There's periods of time where we've had drought, where we needed, a more financially stable or a more stable output of food. There's been times where apparently, the rumor has it, I don't know if this is proven or not, where the government has paid certain farmers not to produce certain amounts of land to produce in order to keep prices stable in the market. Now, obviously, fundamentally, that's something I'm opposed to, as being somebody who's looking out for the man at the bottom, not the bottom, but just for my fellow humans, is that You know, if people want to produce, because who's to say that something doesn't happen and causes a shock in the market, that if this people weren't producing the land, we can't predict the future. And with 100% certainty, there's always the possibility of something going wrong. But that's not what they want to do, and that's not what keeps the market stable. But basically, that is the long and short of it.